Good evening, everybody, and thank you for the brief introduction. Before I start this evening's talk, I would like to thank the organizer of the Sea Secrets, and it's truly an honor to be here and present at Sea Secret. And also I would like to thank the entire Erasmus community, especially the Marine Geology Department, and in particular, Dr. Bob Ginsberg, who initially started the Sea Secret. And unfortunately, he couldn't be here tonight. And also all the faculties and students in the department, because the reason I'm standing here today is because of them. They are a great support for all the research and activities that I do in this school. So to start the talk tonight, I would like to talk about some changes in our vocabulary during the past 40 years and mention some new words which has been entered to our daily vocabulary, and we recently starting using those words over and over in the media, in the publication, research publication, or in the news. What's happening? Okay.
Excuse me, could the volume be turned up a little bit, please? The volume. Yes.
Okay, that's my bad. Thank you. All right. Can you hear me? All right, great. So some of these words are like hazards, vulnerability, and natural disaster, resilience, risk, and these are the new words has been entered to our vocabulary during the past 40 years. And if I'm going to go further, I would like to start defining these words, give you some sort of definition, like natural hazard is a nature event who impacts community in a negative way. Natural disaster is the effect of natural hazard in economic, which resulted in economic, environmental, and human loss. And then vulnerability basically is the community's limit to mitigate the effect of natural hazard. And finally, resilience is the community's ability to recover from the difficulties. So if you pay attention to all these terminology, you find a common denominator. And that common denominator is human factor. When you have a kind of flood in the middle of nowhere, nobody cares about it. We call it a natural event. But the minute that flood caused casualties, we call it natural disaster. So when we add the human into the equation, everything has changed. And it's interesting, some researchers got into processing these words during the past 36 years or 30 years. And they ended up analyzing all of the researchers in the field of human science, climate science, risk management, and try to find out the frequency of the usage of these words and also the relationship between these words. And finally, they published their work last month. And here is the spaghetti diagram of their work. Well, you cannot read anything from it, but let me highlight something for you here. The most frequent words which having the strongest relationship form this love triangle, which I call it love triangle. And those words are conflict, climate change, and natural disaster. In the second order of importance, we have violence and security. So these are the most frequent words in the science publication in the field of environment, climate change, and human societies, technically, during the past 30 years. And by the way, can I have these lights off? It's too much. Thank you. So the next question is, are these relationships between like climate change and natural disaster and climate change and conflict, are these relationships a new thing or has happened before? So I would say, based on new researches started in early 2000, and we were fortunate because most of these researchers conducted by Erasmus scientists. One of the early publications in this field was done by Dr. Clement, who studied the impact of climate variability on Peruvian societies. So here is the publication, has been published in 2001 in geology. And with the help of climate modeling and also archeological studies, they found out that El Nino affected all the Peruvian societies from prehistoric time all the way to the modern era. So this is one of the earliest publications in this field. And the second publication basically as done by our very own Dr. Peterson, who studied the collapse of Mayan civilization. So as you may know, Mayan civilization, they really depended on the freshwater resources. And the fluctuation in the freshwater resources puts a lot of pressure on these societies. And as you can see here, they have to build and go to very serious measures to get an access to fresh water. And what Dr. Peterson and his team did, they reconstruct the climate variability of the past for the duration that known as the terminal classic collapse of Mayan civilization. And here is the time frame starting from 910 AD all the way to 760 AD. During the 160 years of this record, they reconstruct the climate variability. Here is the wet condition, here is the dry condition, and you can see the Mayan civilization, they suffer 4 major episodes of drought, and they are really prolonged, 8 years, 3 years, 6 years. This is another great publication which mentioned the impact of the climate on early civilization. Now let's go back to Asia, Chinese dynasties. A group of scientists, they published their research in Science in 2008, and they tried to reconstruct the intensity of monsoon and the rainfall and tie that variation to changes between dynasties. So here is the results. Here you have the timeline starting 200 before present all the way to, actually this is 200 AD, sorry, all the way to 2000. And here is the wet condition, dry condition, and they reconstruct the intensity of monsoon based on oxygen isotopes. And here are the 3 major droughts, very prolonged, between 20 to 40 years long. And you see the transition between major dynasty has happened exactly right on those periods of droughts. Okay. One of the main questions I normally face is, how can you tell about the climate of the past when you cannot measure anything? How could possibly somebody can measure something like 5,000 years ago? My first answer, and the short one, was paleoclimate research. And then I realized just by saying paleoclimate research, that doesn't do any good because that's not the right answer to it. So I have to explain what is the paleoclimate research. So here is the recipe for paleoclimate research. The first thing you need is the climate archive. You need something which records the climate variability and saves the climate variability. The climate archives are like tree rings, corals, the bubbles trapped in ice cores, sediment cores, and the cave sediments. This is the slab of stalagmites cut in half. So we use these archives to study the climate of the past. And how we study the climate of the past? By measuring something called proxy. Proxy is something you can measure and indirectly interpret it as a climate signal. So these proxies can be organic compounds, different types of elements, isotopes, pollen, and minerals. And by having this, for instance, by studying the changes in pollen, we can tell the changes happened in vegetation, and then we can translate that to changes in water availability. By studying minerals, we can interpret certain minerals as dust input, and then we translate that to dusty sequences and dry sequences. And to collect and analyze all these, we need a bunch of scientists, and they should be happy, otherwise you cannot work with them. So here's an example of happy scientists doing drilling, and here is me taking sediment samples. Sometimes I crawl in the caves to get to the samples. Sometimes we hang from the rope, and we are always happy, although we are covered in bad shit from head to toe. We are smiling not because we came out of the cave in one piece, because we collect the right samples, and we continue to smile when we have the samples in our office. By the way, this is Dr. Poorman, my advisor. And after doing all this hard work, then we need to have a very expensive utensil to cook the data, to produce the data. Here is Dr. Peterson working with the XRF machine, setting up for the analysis. Here is Dr. Swart, and with one of his mass spectrometers. Here is Dr. Poorman teaching a student how to use and not mess with the $2 million instrument. And here is me and Dr. Poorman working at Dr. Peterson's lab, setting up an experiment to measure physical properties of the sediment. So having all these nice instrument and archive, we would like to find a place which we can establish that kind of relationship between climate and the civilization. One of the best locations is go to the cradle of the civilization, right? In the West Asia, here is the region known as the Fertile Crescent. And here's the closer look. You have Mediterranean Sea, Red Sea, Persian Gulf. And for those who doesn't listen to Fox News, here is Iran. And here is the Fertile Crescent. This region is very dynamic with respect to climate, because we have westerlies, which brings moisture from Mediterranean and Atlantic. We have cold front from Siberia, and also we have Indian Ocean monsoon. So now I'm zooming in. Here again is the cradle of civilization. You see two major rivers, Euphrates and Tigris, and the area in between is called Mesopotamia, the birthplace of early civilizations. And here is the Fertile Crescent. Early settlement in this region goes back to 12,000 years ago. But the civilization as we know it today started somewhere around 5,000 years ago, starting with Egyptian in the west, Sumerian in the center part, and of course the Persian on the right. Here is the birthplace of the modern city as we know it today, city like Susa in Iran. And people still living in this city in very modern condition, not in this condition. And here is the city of Babylonia in Iraq. Now I'm going to give you a very intensive crash course in history. This is the birthplace of writing system as well. So the writing revolution happened in this region in a way that Egyptian invented the writing system using pictures and signs. But what has happened in Mesopotamia was they invented a lettering system. And the difference is here, for instance, you use this sign to refer to water, which is nun in Egyptian, Old Egyptian. But also, whenever you want to refer to water, you use this sign. Whenever you want to say something started with N, you use this sign. a name of important person started with N. Also, you use this sign. So it's kind of confusing, and you have to be aware of the context of the text you are reading. But what they did in Mesopotamia, they invented letters. So this is D, this is A, R, Y. And if you happen to know Persian, Dari means you have. So after this, a new era has begun. Era of detailed explanation, record keeping, reasoning, and expressive emotion. Now I'm going to give you some examples. So the first map basically found in 2000 BC, which means almost over 4,000 years ago, in Babylonia. This is the map of Babylonia showing different water canals and buildings with all the description you need to know. And here is the map of the world. Here is the city of the Babylonia in the center of the world, surrounded by the oceans. And you can tell in 2,500 years ago, they believed the earth was round. So the first mathematical concept was born in that region. So this is a famous tablet. You see the square, and this is the right angle triangle. It's called the famous Babylonian tablet, and these are some numbers. At first, you think these numbers, they don't make any sense, but Babylonian had the sexagesimal numbering system, which means they use base 60 instead of base 10, that's what we use today. So 60 was 1. And here is the way they calculated the square root of 2 based on their interpretation. So these numbers, 1, 24 over 60, 51 over 60 square, and 10 over 60 cubed gives you this number. And if you happen to have a calculator, please calculate the square root of 2. It's damn close. It varies on the 6th digit. And this calculation goes back almost 4,000 years ago. So early mathematical concepts generated there. Also, the first poem has been recorded in the history of mankind, was found in that region. A poem by the daughter of King Sargon. And sorry, it's going to be a little bit erotic, but it's a very nice poem. And this is the actual tablet. And this is the poem. So let's now talk about a little bit about the economy of the Mesopotamia since 12,000 years ago. Their economy mainly relied on agriculture, livestock, and timber. And as you may understand, all this division of economy relies on water availability, and the water relies on climate. So they need to keep track of water and climate condition. That's why they invented calendar. So this is one of the earliest calendars, and as you can see, it has 4 quadrants resembling 4 seasons, and they divided it to 12 pieces for 12 months. And they designed this calendar by tracking the position of the sun and the moon, and also try to fit in the agricultural season into the calendar. So to be able to track the climate condition with respect to their needs. And to track the position of the sun and the moon, you have to study the sky. So they literally invented astronomy. And here is one of the oldest tablets they found. It's a part of the astronomical bibliography of Babylonia. And here talks about the astrological properties of the Leon and the Jupiter. The reason I'm telling you all this is to let you know, of course, I would like to brag about my background, but I would like to point out that by any account, these civilizations were as advanced as we are. Just set aside the electronics and the internet and the computer. But the initial concepts that we are using it today on daily basis has been generated by these people. And they were the giants that now we are standing on their shoulders. So next time you take a look at your watch, remember you are doing something Mesopotamian. You check your calendar, you are doing something Mesopotamian. Even when you read, you are doing something Mesopotamian. And if happens to you read horoscope in the morning, you're doing something Mesopotamian. But this is not the entire story. There is another thing. Now I'm going to show you the territory of the Persian Empire through the course of history, going back to 5,000 years ago, and see how it changes through the course of time. Here's the Achaemenids, the biggest empire on earth. They roamed the entire northern hemisphere and then transferred to Sasanians, and then Tahirids, Seljukis. So you see that their territory has been expanded and shrinked through the course of time, and it happens several times. Now the big question is, does climate variation affected this civilization? So to answer this question, we went to Iran, and we found this lake in northwest of Iran at the elevation of 2,700 meters above sea level. And here's the picture of the lake. And here is a group of happy scientists again, and they are taking cores. And finally, we were able to recover 8-meter long core from this peat deposit. And you see these layers, you know, it has different colors. So by using all those fancy instruments, I was able to generate these records, which goes from present time all the way to 13,000 years ago. So this is the variation of titanium, the element that I was interested in. And later I realized this variation, basically you can translate it to dry and wet periods. More concentration of titanium means more dust input, and more dust input happens during the dry condition. But this is only one proxy. And I don't like to rely on one proxy because I can get criticized by people why, if you use another thing, what has happened. So I went ahead and I analyzed many things like iron, aluminum, and even organic carbon, and everything shows the same signal. That tells me, first of all, whatever I'm generating, it's a climate signal, and it can be reproduced by using different proxies. So all my proxies complement each other. And since I'm interested to study the impact of climate on civilization, now I'm going to show you only the first 5,000 years of my record. So here again, this is the titanium wiggle, and this is the actual core, and these are the places that I did the radiocarbon dating. Tying a paleoclimate record to a regional climate condition is a little bit of an art, and it's very challenging. So to do that, I studied all the paleoclimate records for the entire region, starting from Mediterranean all the way to Pakistan. And for instance, this is like a record from the coast of Ashud in Israel, Sorek Cave in Israel, the level fluctuation in Dead Sea lakes, Lake Tisser in Turkey, and Lake Mirabot. And these are all dry conditions, and they very good correlates with my climate signals. So I know that now my climate, my signal not only represent the local climate, but also tells a lot about the regional climate. The next challenge is to dig into the literature and take out all the events and records of famine and drought. So I had to do it in many different languages. So I studied more than 100 books and records in Arabic, Farsi, Turkish, English, and thanks to our great librarians here at Erasmus, they provided me some books published in 1800, and they have them transferred to me from Italy and Germany. And this is a rare commodity, believe me, when you're dealing with ancient texts. So now at the bottom, I'm showing all the drought event, historical drought event recorded in Iran, Mesopotamia, and Eastern Mediterranean. And at the top is the records of famine in Iran, Mesopotamia, and Eastern Mediterranean. As you can see, they are very well correlated with the duration of the dry period. The next challenge is to put all the great dynasties and civilizations and see if we can see some sort of correlation. And yes, we do see the correlation. So all the transition between these great empires has happened during the bad climate condition. And as you can see, it's more than 75% match. The effect of climate has been noted by even the great emperors in the region. So I would say during the past 5,000 years, the battle between kings and climate in Mesopotamia and in the cradle of civilizations, all the great kings has lost their battle to climate. Here is the Cyrus the Great, the most kind and wise emperor of all time. And here is his prayer. God, protect my nation against drought. First he mentioned drought, and then foe and faithlessness. And even Genghis Khan, the greater warrior and fearless warrior, he prayed to sky god to be able to rule the entire world. And now, as a nation of technology, the question is, what would be our prayer? And how we react to climate variability? Thank you.